Item 37 refers to the table below, which shows the relationship between the number of sides and the number of diagonals of a polygon. And they give you the table, and then they ask the question, what is the value of n? Alright, so this is an interesting question because all you have is a table with values. Right? There's nothing in there that hints at any particular rule or any particular law or any particular theorem or any particular formula. This is one of those situations where you have to look at what you have before you and deduce any patterns inside there. Right? As I tell my students all the time, observation is the first law of the mathematical jungle. And this question is a simple variant of what is now your number 7 question in the 2018 syllabus, where you have a kind of pattern, you have some kind of something that is not, it doesn't fit with any particular topic in the syllabus, but it's just about your observation and your ability to deduce patterns and express the pattern that you deduce. So let me check it out. So we have sides and we have diagonals. So the number of sides increasing by 1 as they go up, right? Starting with 4 sides where you have 2 diagonals, right? 5 sides, you have 5 diagonals. 6 sides, you have 9 diagonals. 7 sides, you have 14 diagonals. And 10 sides, you have n diagonals. So these increasing by 1, but then when you go here now, what's the pattern we're noticing? Right? This is an example of what we'd probably call a sequence, right? Some kind of pattern. So 2 plus 3 is 5. 5 plus 4 is 9. 9 plus 5 is 14. So in other words, the amount that you have to add to move from one to the next in this column on the right side here is increasing by 1 as we go along. So 2 plus 3 is 5. We add 1 to the 3. 5 plus 4 is 9. You add 1 to the 4. 9 plus 5 is 14. Which suggests very strongly, and in this case, because we just have 7, this would be 8, and then this would be 9, and then this would be 10. So I could come here and say, let us see, I could say 8, 9. Alright? Now there are questions in the long paper, you'll get questions kind of like this, where the gap between the last value that they give you and the final value wouldn't be as small as this. You might get 4, 5, 6, 7, and then ... 85, 86 going on the road. So in that case, the onus to deduce the pattern will be even more stringent. But that discussion is for another place and another time. Here we're just dealing with what we have before us, which is a very simple table. You have 7 and you have 10, so this will be 8 and this will be 9. So then this will be 14 plus 6 to give us 20 diagonals here when n is equal to 8, and then 20 plus 7 would then give us 27 diagonals for a 9-sided figure. Alright? So that if we have, well, of course, and then of course you have the 27, sorry, and 8, which will give us 35 diagonals for a 10-sided figure. So if we follow this pattern here, we'll end up with 35 diagonals where you have a n-sided figure where n is equal to 10. Right? So in other words, sorry, the number of diagonals is n. So the number of diagonals is n, the number of sides is given here. So anytime you have a 10-sided figure based on this setup here, the number of diagonals, n, would be 35 diagonals. So in that case, the answer is answer D, 35.